You may have heard that the majority of our nation has adopted Common Core standards. These standards were developed by a variety of educators and professionals to prepare students for the modern-day demands of college and careers. One thing the writers of Common Core noticed was that countries that outperformed the U.S. in math had less standards. Their motto was, "Teach less, learn more." As we move toward the Common Core standards, teachers are implementing practices that dig deeper into concepts instead of just brushing the surface. That's especially true when students are taught to conceptualize multiplication and division. Students are given various models to visualize multiplication. Visualizing is helpful, even for students who have a mastery of how to compute mentally, because it solidifies an understanding of what multiplication really represents. Then, when more complex real-world questions that require multiplication arise, students are able to apply their understanding accurately because they understand the deeper meaning of what multiplication represents. Students are taught the strategy of breaking numbers apart to solve a multiplication problem that isn't a fact, or able to be computed mentally and quickly. We started practicing with small numbers like 5 and 9 to gain an understanding of how the strategy works. In this situation, the factor of 9 is broken up into the numbers 5 and 4. This model demonstrates that breaking an array into two smaller arrays and then adding them back together still determines the same final product. Then we move into bigger numbers that can't be computed mentally using the traditional algorithm or old-fashioned way. Students could break this number up into several different smaller numbers, but breaking the number up into hundreds, tens, and ones simplifies it because it only requires one-digit by one-digit facts. If students understand that 0 is a placeholder, these problems will actually be quite simple. Once they have their three products, they add them together to get the final product. This method has about the same steps as a traditional algorithm and also utilizes students' knowledge of addition, multiplication, and 0 as a placeholder. However, this method illustrates more clearly the connection between each place value and the final product, and also capitalizes on students' mental math capabilities. Division is first introduced as the inverse or opposite of multiplication. Students make connections between numbers that are part of the same fact family. Students are taught to visualize division in the same way they did multiplication, with rectangular arrays, intersections, or groups of objects. Once they understand that 12 divided by 3 is actually asking them to divide 12 into 3 groups, they can easily construct a model that will help them find the missing number. In this case, 4. When it comes to dividing bigger numbers, students are taught to break them apart or decompose them, similarly to how they did when they learned multiplication. The division problem 456 divided by 5 can be represented in two ways shown here. The second representation will more accurately show how to decompose these numbers. Students are taught to think of a number less than the dividend, this number, that can still be divided by the divisor, this number. In this case, 400. And know that the corresponding quotient is 80. Students who know their 5's facts through 12 may recognize that they are able to get close to 56 by multiplying 5 times 11 to get 55, but will have 1 left over. That leftover 1 can't be divided by 5 and still remain a whole number, so it remains as a remainder. I hope this slideshow provided you with some helpful tools in reviewing multiplication and division strategies with your child. Please feel free to contact me or your child's homeroom teacher with any further questions.